so this is section 3.4. Okay, it's really a continuation of section 3.3. So if you haven't watched that one, definitely watch that one before this one. Okay, so we solved one just like this before in section 3.3. All right, so it says solve this equation if 1 is a 0 of the function. Okay, what does that last part mean? That means if I plugged in 1 for x, I would get 0 equals 0. It is a 0 of the function. All right, so we need to solve this knowing that 1 is a 0 of the function. Okay, if I just gave you this, okay, your first thought should be, okay, I need to factor this, right? And this has 4 terms, so I would factor by grouping. Once again, grouping doesn't work. Okay, I would group these two. I would take out an x squared and be left with something. Then I would need to take out the greatest common factor of this, which is 1, which doesn't give me the same thing inside my parentheses. Grouping doesn't work. Okay. Then we're going to go to using synthetic division. Okay. We're going to go to using synthetic division. Okay. Your C is whatever 0 you're given. Then you're going to list your coefficients. Okay, bring it down. Multiply. 1 times 1 is 1. -1, -1, -12, -12, 0. Okay, remember that you should always get 0 because 1 is a 0 of the function. So you should always have a remainder of 0. All right, you start 1 power less than what you're given. You are given cubes, so you're going to start with x squared minus x minus 12. Okay, then you're going to factor that new polynomial that you just got. X squared minus x minus 12 equals 0. That's an easy trinomial. Okay, so you have x and x, your signs are different. Your factors of 12 that add to give you -1. Okay, there's an understood 1 right here, so it's going to add to give you -1. So that is 4 and 3, and you want your 4 to be negative because you want your bigger number to be negative. You can always check. Okay. Then you're going to solve. So that means 0 product rule. So you have x plus 3 equals 0, x minus 4 equals 0. So you get x equals -3, x equals +4. Okay. So again, what I just found was that 1 is a 0 of the function. So I used that as my C, did synthetic division. I got this polynomial. I factored and solved that polynomial, and the 2 x's that I found are also zeros of my polynomial. Okay, or my equation, I should say. All right. So what if that extra 0 was not given as a hint? Okay, what do I mean by that? I mean, what if I didn't give you this part? Okay, and I stopped after equals 0. Okay, so what if, I can add this in right here. What if I didn't give this hint? Okay, because that's how you knew where to even start, is because I gave you that 0 of the function. You knew that you were going to use that as your C and do synthetic division, factor, and solve. Okay. If it's not given, then you're going to have to use the rational 0 theorem. Okay. The formal theorem is in your textbook. So if you would like to go see that, go ahead. But this is what it says. It talks about the possible zeros. Okay, this is very important. Possible zeros equals factors of the constant over factors of the leading coefficient. Okay, factors of the constant over factors of the leading coefficient, all right? So let's just take some time to look at all possible zeros. Let's work a few examples on just finding possible zeros, okay? When I ask you for just possible zeros, you will make a list and stop. Okay, you're not going to do the whole problem. You're just going to make a list of all the possible ones, and then you're going to stop. All right. So possible zeros equals factors of constant of the constant over factors of leading coefficient. Okay. All right. The constant, whoops, factors of the constant are factors of your number that's all by itself. Okay. That is your constant. The factors of 10 are 1 and 10, 2, and 5. Okay. Factors of the leading coefficient. Here's a leading coefficient. Here's your leading coefficient. It is the coefficient that is attached to your highest power. Okay. The factors of 2 are 1 and 2. And we are always going to do plus or minus of those. Okay. So that's why I have plus or minus written out. All right. Now I'm going to make my list. So I have this. So I'm going to take each one of my numerators. Whoops, I need to draw that different. And put it over 1. See what I get. Then I'm going to take each one of my numerators and put it over 2 and see what I get. Okay. So 1 over 1 is 1. 2 over 1 is 2. 5 over 1 is 5. 10 over 1 is 10. Okay. Now I'm going to do over 2. So 1 over 2 is 1/2. 2 over 2 is 1. That's already accounted for, so I'm good. 5 over 2. Okay, 10 over 2 is 5. And I've already accounted for that also. Okay. So that is my list of all possible zeros. Okay. This is my list of all possible zeros for that function. Okay. So we can do it again here. All right. You can try it if you want to. All right. We're going to do the same thing though. Possible zeros, factors of the constant over factors of the leading coefficient. All right. Factors of the constant. So that's factors of 14 are 1 and 14, 2, and 7. Okay. Factors of 3 are 1 and 3. So now I make my list, right? So I'm going to put all of my numerators over 1 and then all of them over 3. So I get plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. That was all of them over 1, which is just going to be your numerator again. Then I'm going to put them all over 3. So I'm going to say plus or minus 1/3, plus or minus 2/3, plus or minus 7/3, plus or minus 14/3. Okay, and that is our list. Okay. Remember, when I ask for all possible zeros, you make a list. You make a list and stop. Okay. I'm not saying those are all the zeros. I'm just saying those are all the possible ones. Okay. And that is using the rational zero theorem. Okay. What? There it goes. Rational zero theorem. Right. And this is when I don't, we're going to use this when I don't give you that hint of this is a zero of the function. Okay. Like this. Here, I don't give you a hint. I just say find all zeros. Okay. I do not say find all possible zeros. Okay. Do you see the difference in this question, these two questions, and this question? The other two have possible. That's when you make a list and stop. This one, you're going to have to do some work. Okay. The good thing is that it falls back on what we've already done, but we're going to add something new. Okay. So you're not given a hint. So you are going to use the rational zero theorem. Okay, I'm going to abbreviate that to find a starting point. Okay. Okay. Use rational zero theorem to find a starting point. Rational zero theorem is all possible zeros. Okay. So you want to find the possible zeros. So we'll write possible zeros equals factors of the constant. So that's 30. All right. So that has quite a few factors. So 1, and I'm going to go way down here. 30, 2, and 15. 3, and 10, and 5 and 6. I'm going to scoot it down just a little bit. Okay. Now, you need to do factors of the leading coefficient, which should always be a little bit easier. Okay, so it's 2. So you just have plus or minus 1, plus or minus 2. Now you need to make a list. Put all your numerators over 1. So you're just going to have your numerator over again. Okay, so I'm just going to copy and paste it. So I don't have to write it all over again. Now you need to put them all over 2. Right? So you have 1 over 2, that's new. 1/2. 2 over 2 is 1. We already have that. 3 over 2. 5 over 2. 6 over 2 is 3. We already have that accounted for. 10 over 2 is 5. We have 15 over 2. That's a new one. 30 over 2 is 15. We already have that. Okay. So there's our big long list. Okay. Now, here's the part where it gets a little interesting. We are going to go down this list until you find a remainder of 0 with synthetic division. Okay. Go down the list until you find a remainder of 0 using synthetic division. Okay. In the other problems, when I did give you the hint, now do you see why we didn't have to use this part? Because I gave you the first 0. Here you have to find it. All right. So start with 1. Okay. So we're going to use synthetic division. Right. Here's synthetic. We're going to start with positive 1. Our factors, our coefficients are 2, -9, -11, and 30. That's the coefficients of our function. Oops. Do synthetic. And we're looking for a remainder of 0. 2, 2, -7, -7, -18, -18, 12. We did not get a remainder of 0, so this did not work. Okay? That did not work. Now let's do another one. Okay? So we'll go to -1. So 2, -9, -11, and 30. 2, we'll get -2, -11, 11, 0, 0, 30. That didn't work. Did not work. For the sake of you skipping through this video and not watching it anymore, let's use -2 instead of 2. Okay, so I think that one might work. Okay. -2, so we'll have 2, -9, -11, 30. 2, -4, -13, +26, 15, -30, 0. Yes, that is what we want. That gave us something that works, a remainder of 0. Okay, now you will factor and solve. Okay, so this is where it becomes just like what we've been doing. Okay, your new polynomial will be 2x. We were given a cube, so we're going to go squared minus 13x plus 15 equals 0. Okay, I got that from right here. I'll write it. 2x squared minus 13x plus 15. Okay, remainder 0. Good. We'll use that and we'll factor and we'll solve. Okay, this is a hard trinomial. So if you would like to do bottoms up, just go over to the side and do it, or you can do it right here. That's fine too. Okay, so 2x and x, I'm going to use 5 and 3. My signs are going to be the same and they're both negative. So I'm going to say 5 and 3, and that gave it to me. -3x minus 10x is -13x. Okay. Factor is done. Now I'm going to solve. So I have 2x minus 3 equals 0. X minus 5 equals 0. Add 3. Divide by 2. X equals 3/2. And x equals +5. Okay, so I found my other zeros. Okay, my answer will be the two that I found, 3/2, 5, and I have to include the 0 that worked in synthetic division. Okay, and -2. Okay, so that will be my final answer right there. All right, so what did I just do? I know that was a long problem. Okay, so my first step was using possible zeros to find a starting point. And then I did synthetic, factored, and solved. Okay, so this is when I don't give you that hint. This is when I don't give you a 0. When I give you a 0, you start right here. You get your new polynomial, you factor, and you solve. The trick here, or the part that sucks a little bit, is that you have to use your rational zero theorem to find your possible zeros, and then use synthetic going down that list to find one that gives you 0. Once you find one that gives you 0, and you find your new polynomial, you're good because we've been doing this since last section, right? Okay. So let's do this one, okay? I would love for you to stop and try it yourself, okay? But I will work it out with you as well, okay? So your first stop is possible zeros, right? Factors of the constant over factors of the coefficient. Leading coefficient, factors of the leading coefficient. What's your leading coefficient? It's 1. So your denominator is going to be plus or minus 1, which is just whatever's in your numerator. So when you don't have a coefficient other than 1 right here, your possible zeros are easier because we can just go straight to our list. So we have plus or minus 1. I'm going to spread that out a little bit. 20, 2, and 10, 4, and 5. Okay. There is our list. Okay. Now use synthetic division. We'll start with 1. 1, 8, 11, negative 20. Okay. So 1, 1, 9, 9, 20, 20, 0. Okay, so that one was a little nicer to us than the last one. Okay, we got a remainder of 0. So our new polynomial is x squared plus 9x plus 20 equals 0. Okay, this is our factor part. Easy trinomial. Signs are the same. And we're using 4 and 5 to get 9. Then we'll solve. And get negative 4 and negative 5. Okay, our answer, though, will be 1, negative 4, and negative 5. Okay, we had to use the one that worked, that gave us 0, and then we used the other one too that we found. Okay, so these don't have to be very long. Okay, they're only longer whenever you need to do synthetic division a couple of times to find your 0. Okay, but that's the only way that they're super long. All right, so in this section we went over again, if I gave you a 0, then you do synthetic factor solve. Okay, if I don't give you a 0, you need to use the rational zero theorem, which is finding all your possible zeros, and that's factors of constant over factors of leading coefficient. That's when you make a list. Okay, then I can ask you to find all zeros, not all possible, all zeros. That's when you have to find possible zeros and then use synthetic until you get a remainder of 0, factor and solve using that new polynomial from your synthetic division. Okay, and that's it.